In MATLAB, each function is written in a separate file. These files should have the extension .m. The first line of the file should contain the function header, where you specify which input arguments the function takes and which output arguments it returns. Function can take 0 or more input and output arguments. If you have more than one input or output arguments, you would separate them by commas. It is good practice to write comments in the file, where you describe what the function does and how it does it. You should also write your name so you can take the credit and blame for what you wrote. When you are writing a large file, you can separate it into different sections. Each section would have a section header. The section headers are specified by two % signs followed by a space character followed by the section header. Let's take a look at some example functions. In the first example, we have a function named shout that takes a single input argument, and the function simply displays this word. In the second example, the add and print function takes two input arguments and prints their summation. In the third example, again the function takes two arguments. Instead of printing their summation, it returns them in an output argument A. In the fourth example, we have a function add3 that takes three input arguments, adds them up, and returns them into the variable A. In the last example, we have an add and multiply function that again takes three input arguments and returns two output arguments. The first output argument, A, contains the addition of x and y, whereas the second output argument, m, contains x multiplied by y. And as you notice that I did not really use the last input argument z. When you are writing a new function, first start in the command prompt and give initial values to the input variables. Let's say x equals 5 and y equals 10. But as you are doing that and performing your operations, let's say x equals x plus y, remember that the original values inside x will be overridden. So if you need to repeat this process, make sure that you also repeat the initialization step. And as you are working in the command window and figuring out how to perform the operations and you are sure when you got them, just copy your code and move them to a script file. You can copy the initialization code also, but remember to comment these out when your function is finalized. When your script is complete, you can add a function header. By adding a function header, you would be converting your script into a function. In this problem, we are asked to write a function that is called area of circle that will take a single input argument, which is the radius of the circle, and return the area of this. We will begin by typing edit, which will open the editor, followed by the name of the file that we would like to create, which is area of circle. MATLAB will ask if we would like to create this new file. Let's say yes. The function header should include the output arguments, in this case the area equals the name of the function, area of circle, and then inside the parentheses we would write down the input arguments that this function will take. In the next line, we will write a comment that describes what this function does. This function calculates the area of a circle given its radius. Before we write the actual expression that will calculate the area, let's go back to the command window and practice typing this expression in the command window. Let's give an example value to radius. Let's say 2. And then try to figure out an expression that will calculate the area. So that will be pi times radius, or in other words, radius squared. And the result will be 12.5, which looks right. And inside the function, we will calculate this expression, but instead of having it printed, we need to store it in the output argument. And let's make sure that we end the line with a semicolon. So the output is not really printed, Instead, it is returned from this function as the variable area. Once we have written this function, make sure to save it and then go back to the command window. And the way to call that function will be by typing the name of the function, area of circle, and inside the parenthesis we will provide the input argument, which is the radius, equals 2, and we will as a result get the area of the circle. In the next problem we will write a function, volume of cone, which will now, instead of taking a single variable, it will take two input arguments, radius and height, and calculate the volume of the cone using this formula. Let's go back to MATLAB, say edit, and then the name of the function, volume of cone. MATLAB will again ask whether we would like to create this file. Let's say yes. Let's type in the function header, function volume equals volume of cone, and then input arguments will be radius and height. Now we can write an expression for the volume, which is volume equals 1/3 times pi times radius squared times height. MATLAB will calculate radius squared first, but if you are not sure about the operator precedence, the safe way to get out of this is to just enclose it in parentheses to make sure that it is being calculated before the other multiplication operations. So let's just do that to be on the safe side. And the function is complete. Now we are ready to test it in the command window. We will type its name, volume of cone, and then provide two values, 3, 2, and we get 18.8, which looks right. Let's take a look at step by step how MATLAB executes this function call. As soon as you hit enter after the function call, the values that you provide as the input arguments will be copied to the input variables. So radius will become 3 and height will become 2. After that, MATLAB will execute your function line by line. In this case, we have a single line. It will figure out the value for this expression and store it in the variable volume. And the variable volume will be returned out of this function since it's the output argument. And it is returned back to the command window. The command window displays it as the answer variable. One important thing to keep in mind is that the radius variable in the function has nothing to do with a radius variable that's in the command window workspace. So I could say radius equals 1000 in the command window. This will not change the result of calling the function as before. You will get the same result. You can think about the functions having their own rooms, and those rooms will be separate from the command window workspace. Each room will have its own workspace where you have boxes in these rooms. And these boxes have names. Even though the names of the boxes may be the same, they are in different rooms, they would contain different contents. In the last example, we will write a script, not a function, a script that has the name cone example, and it will ask the user for a radius and height of a cone, and it will print its volume by calling the volume of cone function that we just wrote. Again, we will start by saying edit cone example. Now we no longer need the function header since we are trying to write a script. Let's ask the user for an input, enter radius, and store the number that the user will enter in the variable named radius. We will repeat this for the height, ask the user to enter the height of the cone, and finally we will print the result using fprintf. The volume is %f, meaning we are trying to print a floating point number, and then a \n, which stands for a new line character, followed by the number that we are trying to print, and we will retrieve that number by calling the volume of cone function that we wrote, radius, height. So MATLAB will first ask the user for a radius, and store it in the radius variable. And similarly, it will ask for another number and store it in the height variable. In the last line of code, it will call the volume of cone function, and whatever that function returns will replace this expression. And then fprintf will print the number returned by the volume of cone. Let's now test this in the command window by typing the script name, cone example. We do not provide any input arguments since this is not a function, it's a script. And MATLAB will execute it line by line. Let's say radius is 3 and height is 2, and we get the volume printed as 18.8. One important distinction that you should note here is that scripts share the same workspace as the calling workspace. So in this case, we called the script from the command window workspace, and the variables that were defined in the script will be the same variables that are defined in the workspace. So when the user entered a number and we stored it in the radius variable, this changed the radius variable that was available in the workspace. MATLAB has a function called save that lets you save variables from your workspace into files on your computer, and you can later reload those variables from the files. And this can happen after you close MATLAB and reopen MATLAB, and the files will still be there. You can restore the variables from those files. Let's try some of these examples in MATLAB. So I will create a variable named A, that's a matrix, and then save it in a file named mydata.txt. The first argument to save specifies which file you would like to save in. The second argument specifies which variables you would like to save. And the last argument specifies in which format you would like to save the variables in. I'm asking the save function to write it in ASCII notation, meaning I want to write it in human readable format so I can open and view the file. After I execute this line of code, the current folder will contain a new file named mydata.txt. I can double click on it and open it in the editor window and see the contents of this file, which is a matrix of numbers. If you don't care about having a human readable file, you can omit the last argument and save it in binary format. Now if you open this file again using the edit function, which will open the editor, you can see that it's no longer a human readable matrix. It's written in binary format, that is in MATLAB's internal binary representation. You can later take this file and load it using the load function. If you would like to save all the variables that are available in your workspace, you would omit the second argument to the save function. In this case, the workspace contains a single variable A, which will be saved in the file mydata.txt. But if you had another variable B, let's have a random number, and you call save, it will store all the variables in your current workspace to the file called mydata.txt, and you can later call the load function to load the variables from the file back to the MATLAB.